Hey everyone, I hope you're doing well. My name is Aakash Singh. I'm a software engineer and I started coding when I was in school, exactly the same age as you guys are right now. So, with the help of these videos, I want to explain a couple of things about Python language and how you can write a code. You can definitely find theory on the internet. या अगर आप स्कूल में पढ़ रहे हो तो आपको थ्योरी के बारे में बहुत पढ़ाया जाएगा, but they generally don't teach you how to write a proper Python program. So in this video we'll be looking at the calculation based programs जहाँ पर हम लोग formulas या फिर कुछ logic decide करके programming करेंगे. And before we begin, a couple of tips while writing a Python program. Specifically for this video, we'll be looking at formulas. The formulas first have to be converted in a way that Python can understand it. In the session, we will also look at a couple of other techniques where you create temporary variables. आप सिर्फ एक या दो वेरिएबल्स से काम नहीं चला सकते हो. If you want, you can add more variables to your program, given that your program starts to work in a better way. We can also use flags and counter variables. It is just like your red light and green light, but inside a Python program. Also using a couple of techniques of finding the last digit of a number, or maybe finding if a number is even or odd. All these things help you write better code. So let's start off with the first problem, जहाँ पर हम लोग एक बहुत ही simple question देखने वाले हैं. Write a program to calculate the area of a triangle. The first thing which comes into our mind is that the area of a triangle is half into base into height. So this would be the formula of a triangle, area of a triangle. What do we need the input from user? What are the inputs we need? First of all, we need to input the base. Secondly, we need to input the height. So I will be taking variables of the same name. मैं कुछ अलग b and h नहीं लिखूंगा. I will just use the same name. Okay, so in Python language, if I want to write the formula as this, I just need to write pretty easy, right? And some of you might be thinking, why did we take 0.5 and why not 1 by 2? 0.5 is easier to write, and also you can use this notation also. But in Python, whenever we are calculating percentages, जब भी हम लोग fractions में calculations कर रहे हैं, if you know what the fraction is, like 1 by 10 is 0.1, 1 by 2 is 0.5, you can just directly write in the decimal format. So let's see how this program looks in the Jupyter notebook. I've already written it down. We have the base, we have the height, and I've also stored the area inside a variable with the following formula. Looking at the area of triangle, we can get this output 76.5. So you can also change it to decimals or not decimals. It's your call, because in Python language आपको specify नहीं करना होता है if it's an integer data type or a decimal. Python automatically determines that. So first problem was pretty simple. Let's look at the next one, जहाँ पर हमें EMI calculate करनी है. Again, in such problems, the most important thing that you need to remember is the formula itself. So I have written down the formula. The next step would be to determine what are the inputs from the user. So हम लोग user से principal amount का input लेने वाले हैं, monthly rate of interest, and the number of months. Now, in a general case scenario, number of months will not be in decimals, it will only be in integer type. Rate of interest will be in percentage. So let's say if I write 5% in on paper, but for Python, I have to convert this into the mathematical notation of 5 by 100, which means 0.05. And P is the principal amount. It can be in integers, it can be in decimals. So once we have determined what are the inputs, these are the inputs, and this would be the output. So let's just convert it into a way that Python can understand it. I say I will be taking the same name of the variables, P into R into. So for exponential notation, I have to use 2 asterisks, which means raise to. Okay, so this is the numerator, but we also have a denominator for this entire thing. So we take this inside the brackets and divide by again the denominator, exponent, which is raised to n, and minus 1. So this is a format which Python can actually understand. So I've already written down the program where we have the input P, rate of interest R, the number of months, which is n, equal to 12. Now, if I want to print something like this, EMI is, and I print the value of E. So EMI would come out to be 112 point something. So it makes sense if you have about 1000 rupees, percentage of rate is 5%, and for 12 months, the EMI should be just above some 100. Okay, so this was the second problem. Again, quite easy. You just have to convert a simple mathematical formula into something that Python can understand. Next program would ask you to calculate tax or generally GST. So it has a simple formula. For this, we need the GST rate. So let's assume that GST rate is 12%. Okay, so this would be the input from the user. And also the other thing you need to take the input from the user is the price. Price can be any decimal or integer value. So again, for the GST rate, we need to convert this into its mathematical form, which is 0.12. And let's take price as 1000 again. And if I want to find the final price or the amount, it should look like price plus GST into price. So original price, and we are adding the total GST to it. So this would be the GST amount. I hope it's clear till now. It's just basic mathematics. You're just converting percentage into numerical terms. Wait just a moment. Yep. Okay, so I've already written down the program. You can see price is 1000, GST is 12%. Final price is GST into price. And also adding the main amount. Print total price. So that would be in the variable final price. But what if I just want to print the GST amount? I can also write that total GST amount, and it would be nothing but this value. So in order to print this, I can directly write it like GST into price, or I can create a separate variable which stores this value. In either case, you will get the same answer. So total price is 1120 and total GST amount comes out to be 120 rupees. Again, quite straightforward, just converting mathematical formulas into something Python can understand. The next problem will have some more element to it. We will be using if-else conditional statements. So let's first understand how do you calculate tax. So Government of India has given certain slabs. This is your yearly income. And this is the tax rate. So how this works is, if your income is less than 2.5 lakhs, there is no amount to be paid, which means your tax rate is 0. But if your income is above 2.5 lakh, but below 3 lakhs, your income is taxable at the rate of 5%. But the taxable income is whatever your amount is. Let's say your income is 2,75,000. So the tax won't be on this entire amount. It will be this minus the lower limit, which is this. Similarly, if I have income of about 4 lakhs, the tax percentage would be 5%, but the taxable income would be 4 lakhs minus 3 lakhs. So the amount of tax would be 1 lakh into 5%. Similarly, for all the other slabs, you calculate it accordingly. So how do we convert this into a Python program? So let's have a look at the Jupyter notebook. So again, I have kept a couple of variables here. So let's first see what are the variables which we'll be using. The first variable is income, which we need to input from the user. It can be anything, any value between 0 to, I don't know, infinity, but that's not possible. But anyways, taxable income stores the amount at which your income will be taxed. So it is exactly this thing, 2.75 minus 2 2,550,000. So basically 25,000. So we are calculating taxable income as your income minus the lower limit in which your slab falls. Next is the tax rate. We'll be storing this tax rate in this variable. And finally, we're calculating the tax. So these are the variables which you're going to take. Okay, so let's look at the conditions. First of all, let's assume my income is less than 2.5 lakhs. So for that, I create an if block which says, if my income is less than 2.5 lakhs, my taxable income is 0 and my tax rate is also 0. So the way this program works is, you have to find out your taxable income and your tax rate. There are other ways to solve this problem, but I'm using this approach because it's the simplest approach that you can find. So what if the income is not less than 2.5 lakhs? If it's greater than 2.5 lakhs, you can write this block where you say your income is greater than 2.5 lakhs and less than. So looking at the slab, which is 3 lakhs. So taxable income would be your income minus the lower slab. And your tax rate is 5%, as we already saw. But if this is not the case, then we say if income is greater than 3 lakhs and your income is less than 5 lakhs. I hope this is correct. Yes. So what your taxable income and tax rate become are, taxable income is income minus the lower limit, which is 3 lakhs. And the tax rate actually stays the same. It does not change. I'm just copy pasting because it's easier that way. And if you have a practical exam, you can also do the same. But it's a different scenario if you're writing it on paper. It gets difficult then. In the next block, I want to take another condition where my income is greater than 5 lakh, but less than 10 lakhs. So again, my taxable income becomes my total income minus the lower limit, which is 5 lakhs. And the tax rate increases to, I think, 10%. No, it's 20%. Right? So we have 4 slabs done and the last one is remaining. In the last one, you can use elif income is greater than 10 lakhs, or you can just use the else block. Assuming that no one inputs a negative salary, in that case, this block will be executed. So this is a taxable income and the tax rate has increased to 30%. So now using this, we have our taxable income and we have our tax rate. So it would be really easy for us to calculate our final tax price. So tax amount would equal to taxable income into tax rate. So this would give us our you need to pay and printing the tax amount. So for this, I am taking it as 10 lakhs exactly. Okay, so you need to pay 0. That shouldn't be the right answer. Taxable income. Let's just look at the program. Where is the error? All right. Income is less than 2.5 lakhs. Let's try to take another input of 3 lakhs and see what the output is. Yes, so I think this would be right. If I increase it to one more zero, you need to pay, right? So I think the variables were not updated there. Okay, so in this program, you have to check for one more thing, that you are writing the equal to signs. So that's what was missing. It plays a very important role, because if I put 10 lakhs here and the equal to sign is not there, it will not go into any of the blocks and the variables will still stay the same. So now I have edited it. I think we should get the right answer now. Okay, so this is our tax amount. Okay, so this is how you can create a program which calculates your income tax. Now it depends on the slabs. The slabs can change each year. So accordingly, you can change your Python program as well. Looking at the next program where we have to find the average and grade for given marks. Now we all study in schools, used to study actually. So we used to get our marks in mathematics, physics, chemistry. In our report card, we have a percentage associated, we have a grade, maybe it's A plus, maybe it's A, maybe it's B. So using this program, we want to find out what is the average score of the student and what is the grade that he's getting. So making it quite simple, let's just say we are taking physics, chemistry and mathematics marks from the user. This is your input. Your output would be your average marks and your grade. So simply speaking, in order to calculate the average, what you need to do is you can add all marks, then divided by the number of subjects. So it's a very simple approach. But while calculating the grade, you need to refer to the average score. So for this, I'll be considering this notation. So if your average marks are between 90 and 100, you get an A grade. If it's from 90 to 80, you get B grade, and so on. There is another way which you can create this program, is not giving the grades such as A and B, but giving the pass and fail. In order to create this, you just have to say if your average marks is greater than 33, you print pass. Else, if your average is less than 33, you print fail. So let's see how this program looks in a Python notebook. Okay, so over here, I have taken the three variables, maths, physics, and chemistry. So we are calculating the average marks and storing it in the variable AVG. So for the second case, where we just have to find out if the student has passed or failed, we can use this conditional block which says if average score is greater than 33, you can print pass, else you'll print fail. So with these marks, the student is definitely failing because it's too less. If I want to create some other notation of creating a grade, let's see how we can do that. So if your average is less than 100 and average is greater than equal to 90, so print A grade. So the next block could be greater than equal to 80. You can print B grade. Just copy pasting the block again. For the second block, I'm giving the C grade. Also, you can create as many grades as you like, depending on the problem that you're facing. So in the last one, I'll be just writing else print D grade. So with this, I can also say average marks are printing average, and also So that it looks good, I will be printing it before printing the grade. Okay, so this looks good. So average marks are 18 and the grade is D grade. Let's try to increase the marks. 58 and probably 88. So average marks are 75% and the student has received a C grade. All right, so this is how you can create a simple program to calculate your percentage, maybe some other grades, or maybe just to find out the total of your marks in all subjects. Okay, so this was all calculation based. Let's move on to a bit of more logical type of programs where we try to find out the factorials, or maybe what are the divisors, how you can find out the prime numbers. So the first program that we see here is to generate divisors of a number. So we have all studied divisors. Divisors means if a number can divide other number completely, that is a divisor. For example, if I have 15, the divisors of 15 are 3 and 5. Also, do not forget number 1 and the number itself. So these all are divisors. But for a prime number, there are only two divisors, which are 1 and the number itself. If a number has any other divisors apart from these two, then it's said to be a composite number. So for this program, we'll be generating divisors of any number. Let's take an example of 15. So the input from the user will be n. Let's take the example of 15. So in a very simple logic, in order to find out the divisors for any number, we start it by dividing from 2, 3, 4, 5 till the number itself, or maybe one less than the number till 14. So if I start dividing 15 by each of these numbers, I can find out what the divisor is. But is this the right approach? Do we actually need to go till 14, or can we cut down the range till a half part? Let's take another example of n equal to 100. We know that 2 divides it. We know that 3 does not divide it. We know that 4 divides it, 5 divides it, and so on. But after reaching 50, you can be very sure that no number greater than 50 can actually divide 100. So what we can find out is we need to create a range from 2 till n minus 1, or basically n. So if any number is given, you have to find out if each of these numbers within this list can divide the number or not. I hope the logic is clear now. So how do we create this? We use range 2, but we need to write n plus 1. This should be n by 2, right? Because we do not want the range to go till the last part. Okay, so let's see how this program looks in a Python notebook. So I've already written down this program. Let's see how this is working. The input from the user, I've taken it as 150. Now this part is actually important, where I'm creating the range. So as we know, we do not want to include 1 because it obviously divides every number. We start from 2 and we go till the half of the number. In this case, this value should be 75. The reason we are adding plus 1 is the range function goes only till n minus 1. And the next step would be to check if the values inside the range function are actually dividing 150 or not. So for that purpose, we are using the percentage sign, which tells you that if I divide n by I, and if the remainder comes out to be 0, it means that I is a divisor for n. So executing this, we get the answer. If I try to change it to something like 1780, I also get all the divisors for this number. I can also increase it. So with each value that the user inputs, you will be getting all the divisors for that particular number. So this approach is a very simple approach for finding the divisors of any kind of number. So let's look at another important program, which is finding the prime numbers. And the logic which we are going to use in this program is actually derived from the previous one, जहाँ पर हम लोग divisors find out कर रहे थे. So for any number, if you want to find out if it's prime or not, the number of divisors will always be greater than 2. If the number is 15, the divisors are 3 and 5, additional to 1 and 15 itself. So we can find out that if this number, so there are two divisors. If the number of divisors is greater than 0, we can say that the number is composite or not prime. But if we have a number like this, 17, the only divisors it has is 1 and 17. So the number of divisors will actually be 0 here, and you can say that it's a prime number. So using this logic, we can find out for any number if it's prime or not. So the inputs which we take from the user are n, which is the number. And then we try to find number of divisors for a given number. So this is the first approach, a simple approach that we can take. There are also other approaches that if the number of divisors is greater than 0, you can directly print that the number is not prime. You can do that. So let's see what logic we can use to find out if a given number is prime or not. So let's say I'm taking the value of n as 17. I'm creating a for loop. Again, in order to find the number of divisors, you need to create a sequence which goes from 2 till half of the number. So for I in range, okay, so this is the first line. If the number is divisible by I, we can say, or basically let's just start by counting the divisors. So for this, I'm creating a count variable which will be storing the number of divisors. I can say count is increased by 1. Right, with this we will get the number of divisors. Then finally we can say if count is greater than 0, then it is not a prime number. But if it's equal to 0, then we can just say it is a prime. Please keep in mind that we are not including 1 and the number itself. So yes, 17 is a prime number. 170 is not a prime number. Is there any other way that we can do this? So right now we are using another variable to store the number of divisors. The other way could be to use a flag variable. Now, what is the use of a flag variable? Sometimes in a program, when a variable changes its value from original one to final one, it can indicate something. So in this case, I will just say flag prime is 0. Okay, so if this flag prime variable changes its value to 1, I can say that the number is not prime. Something like this. So if the number is divisible by any of the numbers within this range, I can say that flag prime has converted to 1. Or maybe let's make it easier. 0. 0 means no, 1 means yes. So initially we are saying that all of the numbers are prime. But as soon as we find out that this number has any divisor, we can change the value to 0. And then we can say if flag prime is equal to 0, then number is not a prime, else it is a prime. So the only difference is in one case we are counting the number of divisors, and in the other case we are just using a flag variable. So as I talked about in the start of the video, this is the use of a flag variable. You can remember it because flags, temporary variables are generally used across a variety of Python programs. So in this way we can actually find out if a given number is prime or not. Let's look at another problem which is also dealing with prime numbers, but in this case, we need to find or write a program which will search for prime numbers between 15 and 25. So what do we already have? The first thing is we can check if a number is prime or not prime. We already have this functionality with us. We just did it in the previous problem. And in order to find the prime numbers between 15 to 25, we need to check for all of these values: 15, 16, 17, 18, and 25. Okay, so if we can check this is prime or not, if it's not prime, we print it. Actually, not print it. This is not prime, this is not prime. 17 is a prime, so we print 17. So can you see the sequence which we are going to create here? The first sequence would be to find 15 to 26, this part, and then we check if I is prime or not. So in order to do this, we just need to create a separate function. Let's see how we can do this. So this problem, I'm just copying it and pasting it down like this. Okay, so let's make it a general output, general input. Right now, what I'm trying to do is I'm trying to print it is not a prime and it is a prime. Let's just remove this. Now, if I input any value of n, like this, and then check for the number, and I return the flag value. So if the flag value is 1, let's say I input 15, all the calculations are done, and the flag value changes to 0, it means the number is not prime. So right now I am returning this value. So this is known as the input variable, and the return value means it is what the function will give out. So this is a function for checking the prime number. And what we discussed, creating a loop, creating a sequence from 15 till 25. Like this. I hope you are understanding, it is not too confusing. This function is used to check for the prime. हम लोगों ने function कैसे बनाया? We copied this entire thing and pasted it here. That's the first step, easier one. But we have converted it into a function. What a function does is, when I call check prime and मैंने इसके अंदर कोई भी value डाल दी, let's say 15. Okay, so let's take an example first. I have made this function, and if I say check prime and I input any number in it, like 17, it will give me the value of 1, which means that the number is prime. If I change it to 179, again, it's a prime number. This will give me the output of 0, which means it's not a prime. So this is what this function does. So the next part of the problem is creating the loop. So creating a sequence from 15 till 25. Now I'm calling this function again, check prime. Check prime I. So if check prime I is equal to 0, then you don't need to do anything. The only places we need to print are the prime numbers. So if check prime of I is 1, then we can directly print the value of I, which means that I is a prime number. So executing this program, we get 17, 19, and 23. So repeating again, we created a function to find if the number is prime or not. Then we use this function inside another for loop to check for each of these values and print the prime number. So I hope this was easy to understand now. We started off by finding the divisors. हम divisor कैसे find out करते हैं? हमको range create करना होता है from 2 till half of the number. then check for the number that if this number is divisible by all these digits inside a range, then we saw how we can use it inside a prime function. Let's see the other type of programs जहाँ पर हम लोगों को calculations and logic use करना पड़ता. And the next one is actually a very important Python program, which is to read an integer and reverse the number. So there are a couple of parts associated with this program. Let's take an example first. If I have a number 79 and I want the output to be the reverse of the number, or let's just say 179, I want to reverse it into 971. So in this program, we will be using a temporary variable. The reason for using a temporary variable is, let's say this is the temporary variable. What I start by doing is, I extract the last digit from the original number, and instead of storing it in the last position again, I can store it in the first position. Then I can take the middle digit, I can store it in the second position. Then I take the first digit and then I store it in the last position. So the place where we are storing these digits is the temporary variable itself. So let me just repeat. In order to convert the number into its reverse, we create a temporary variable जहाँ पर हम लोग सारे digits in reverse order store करते हैं. But how is this reversal possible? So there are two steps here. Step 1 is extract the last digit. Okay, so how do we extract the last digit? Let me give an example. So if I say 11 and I found the last digit, which is 1, I simply divide it by 10. Or maybe we can use the percentage sign 10 and we will get the last digit. If I want to find out the last digit of 17, I divide it by 10 for the percentage sign. This will give me the remainder, which is 7. So in both of these cases, the remainder is 1. In this case, the remainder is 7. So remainder essentially means that it is the last digit of your number. What should be the remainder for this? It should be 0. Right? So the last digit comes out to be 0. So extracting the last digit means we divide the number, let's assume it as 10, by 10. So in this case, what happens? 179 percentage 10. What does it give us? It gives us 9. So the next step would be to, let's call the temporary variable t. I store this in t. Okay. The next part would be to remove the last digit. Why are we removing the last digit? Because in the next iteration, when we want to find out 7, we need to remove this 9. So let's say if I remove the last digit from 179, the digit becomes 17. Then I can again use the same way to find out the middle number. Then I can again find out the next part by dividing this. So, but how do we remove the last digit? In order to remove the last digit, we perform this calculation. N is actually floor divided by 10. So let's say if I divide 11 by 10, the floor division, the quotient that I get is 1. If I do it for 17 also, I again get 1. So in order to remove the last digit, we perform this calculation. So in the next step, what happens is, this gives me 7. correct? Now this 7 needs to be stored with 9 like this. यहाँ पर आना चाहिए 7. But what is the calculation that is necessary? So in order to do this, we multiply 9 by 10 and then we add 7, right? It is simple mathematics. Then we again remove the last digit, which is 7. We get 1, right? And then we again multiply the entire thing by 10 and then again add the last digit. So this is a way you can actually reverse the number entirely and print the value of t. This temporary variable will store your reverse number. So let's try to execute this logic in a Python program. Okay, so taking the number as anything, let's say 179 itself, naming the temporary variable as temp as 0. Okay, so now we want a loop which can extract 3 digits. So for this purpose, I'll be using the while loop and I'll be saying while n is greater than 0. Why I am doing this, we'll have a look at that also. But let's start off by saying last digit is n percentage 10. Now I want to store this last digit in the temporary variable. But remember, every time we are adding a new digit, we need to multiply it by 10 plus last digit. And then we again need to change the value of n by removing the last digit. So why we are using a while loop is every time the value of n changes, it goes from 179, then it goes till 17, then it goes till 1, and then it becomes 0. As soon as all the digits of of the number are over, the loop ends. So this is the reason we are using a while loop. It will only execute 3 times because each time we are removing the digits. And then we can print reverse of the number is 971. You can make any number of changes here, but it will give you the right answer. So this is a simple logic of how you can reverse a number. The things you need to remember, these 3 statements will help you a lot in the near future as they have helped me. Extracting the last digit, storing the digit in a new number, and then removing the last digit. Using this logic, we can solve other programs like a program to check if a given number is palindrome or not. So what is a palindrome? Let's say I have a number like this, 6776. If I reverse this, I will again get 6776. If I say 1331, it will again give me on reversal 1331. So in order to check if a number is palindrome, the best thing that you can do is your initial number is equal to your reversed number. So this is the logic which we can use. Let's try to implement it. So I'll be copying the entire thing again. It's easier that way. So right now I have a number, but if you see this n changes every time, it does not stay the same. So in order to store its value like this original number, I can say n, so that later on I can actually compare the original number with the reverse number. Let's just name it reverse, right? What this thing does is I need to change the variable names here. like this. And then finally, I just need to compare if original number is equal to reversed number, I can just print number is a palindrome. Else, if it's not, you can just print out whatever the statement you want to output. Not a palindrome, right? So what is the logic? We are initially storing the value of n in an original number so that later on we can compare it, and we are using the same approach as reversing the number. So this is not a palindrome, obviously. I just replace it by this 1771 and execute it. The number is a palindrome. So this is the logic for extracting the last digit, reversing the number, and checking if it's a palindrome or not. Now, extracting the last digit, the logic is also used in other kind of programs like this. So we need to find out if a given number is Armstrong or not. Simply speaking, the Armstrong number is the sum of cubes of individual digits. If it's equal to the original number, then it's an Armstrong number. So this example does a perfect job to explain this. If I have a number 153, the cubes of individual digits and the sum of it is equal to the original number. If this equals this, then it's an Armstrong number. So can you think of a way? How do we find out if a number is Armstrong or not? So we can see that the digits are extracted. So what is the approach that we took to extract the digits from the original number? We were using percentage sign and then we removed the last digit. It is the same approach here. So let's try to execute this in a Python program. Okay, so I have a number, let's say 153 itself. Creating a while loop in order to check the reversed number or maybe extract the digits one by one. N is greater than 0. Why n should be greater than 0? Because once all the digits have been removed, the value of n becomes 0. We can say digit is n percentage 10. Now we also want to store the sum of individual cube of digits. So for that, I just say sum is 0. So I increase the value of sum by digit raised to 3. So does this approach seem familiar? We are just changing this line. Instead of storing the digits in a reversed format, I'm just taking the cube of the individual digit and adding it to the sum. Now again, I am changing the value of n by removing the last digit. Finally, if we find out, now I cannot compare n with sum. Do you get why? Because the value of n is now very different. It's changed to 0. So for this, I can just say OG number is n initially. So if OG number equals to sum, then I say number is Armstrong. Else I can just say number is not Armstrong. So what should be the output for this? It should be Armstrong, right? Number is Armstrong. If I change it, number is not Armstrong, right? So with one tip, one approach, you can solve multiple types of problems. Just try to remember the approach of extracting the last digit. So the last problem for today, write a program to check whether a given number is perfect or not. So in order to find out whether a given number is perfect or not, the way we do it is we find the divisors. Again, going back to the problem where we were trying to find out the divisors. I say these are all divisors and then I add them up. If the addition or the sum of divisors is equal to the original number, then I say the number is perfect. So what do we need for this program? We need to find all divisors of a number. We need to sum them and then we need to compare with the original number. So this is the process which we are going to take. Okay, so first of all, finding the divisors. Do you remember how do we find the divisors? Let's say I am taking the input as 28, creating a sequence from 2 till half of the number, which is this. Now I also want to simultaneously store and add the number of divisors. So I can just say sum of divisors is initially 0. Okay. Now, if n has a divisor in I can just add it to this value. Every time I encounter a divisor, I just add to sum of divisors. Like this. So this loop takes care of finding the divisors. Finding the divisors is this statement and adding the divisor to the total sum. And then finally, if sum of divisors equals n, right now we don't need to change the value of n because in the for loop it never changes. We can just say perfect number. Else we can just print imperfect number. All right, so let's execute this. It says imperfect number. Is it imperfect? All right, so one change that we need to do over here is we also need to add 1 and the number itself. So there are two ways that you can do this. You can initialize the sum of divisors by adding n plus 1, right? Already adding the number itself and the 1. Or you can also make some changes in the range. I prefer not making changes in the range because this same logic has been used at multiple places, so it's easier for you to remember. But while initializing the sum of all the divisors, please add the digit 1 as well as the number itself. So let's see how it changes. So there seems to be some programming logic error. Okay, so in order to do this, let's try to print the value of I, which will give us 2, 4, 7 and 14. So that should be right. Okay, so right now we don't need the number itself. We only need 1. So that is the reason for this error. So I hope you understood. There was an error in addition. यहाँ पर हम लोगों को 1 and the number itself नहीं चाहिए, हम लोगों को सिर्फ 1 ही ऐड करना है. So instead of initializing it with 0, I am initializing the sum with 1. So indentation error. Yes, there is an extra variable. So yes, this is a perfect number. I hope it was not too confusing. Let me just change it to something else, 281. It is an imperfect number. So this is how you can create a program to find out if a number is perfect or not. If you want, I can share these programs with you on the Telegram group, but I hope you were able to understand all of the logics which were covered in today's session. Most of them are very important: finding out the last digit, finding out the remainder, reversing a number. imperfect numbers. So if you were able to understand this, then well and good. But if you have any doubts, please do not forget to comment under the video. I'll be able to help you out there. If you found this video useful, please put a like. It helps me create more videos. I'll be seeing you in the next one. Till then, stay awesome. Bye bye.